Hello and welcome to Earthquake Tip number 27. My name is Shailesh Kumar Agarwal, Executive Director of BMTPC, and I'm going to present to you all about earthquakes, its concepts, terminologies, and how to construct buildings and structures to withstand earthquake forces through 32 earthquake tips, which are authored by Professor C.V.R. Murthy, mentored by Professor Sudhir Kumar Jain, and developed by IIT Kanpur in association with Building Materials and Technology Promotion Council, that is BMTPC. Through these tips, our aim is to spread right technical information in simple to understand language to our professionals who are in the field designing and constructing structures, especially our architects and engineers. But before we start, let's make a pledge that any new structure we design or build must be earthquake resistant. This earthquake tip number 27 will explain you how can non-structural elements be protected against earthquakes. We already know structural elements in building resist the effects of earthquake ground shaking and protect the life and property of building occupants. However, the building contains many other items such as contents, appendages, service and utilities which are either attached to or supported by structural elements and affected by earthquake ground shaking. These items are called non-structural elements. Let me further elaborate these non-structural elements into these three categories. First is contents of buildings. It includes items required for number one, functionally enabling the use of space such as furniture, storage shelves, etc. Second, facilities and equipment such as refrigerators, false ceilings, multi-level material stacks, etc. Third is door and window panels and frames, plywood or aluminum partitions. Second is appendages to buildings. It includes items projecting out from buildings either horizontally or vertically, such as chimneys, exterior glass or stone cladding, parapets, small water tanks, sunshades, advertisement hoardings, antennas, etc. Third classification is services and utilities. These are items required for facilitating essential activities in the buildings, such as water mains, electricity cables, air conditioning ducts, rainwater drain pipes, and elevators. Having understood these non-structural elements, let's see earthquake effects on non-structural elements through this figure 1. During strong earthquake shaking, non-structural elements can slide or topple or move or swing if they are not secured well to structural elements of the building. These actions can cause loss of functionality of non-structural elements and potentially precipitate second disasters such as spill of chemicals depending upon its importance, as you can see in this figure 1a. Loss of functionality of non-structural element can be small or substantive depending upon its importance, the function it serves, and its cost. As you can see in this figure 1b, if the bookshelves of library are not properly secured, they can distort or topple. If distorted, they can dislodge books, but if toppled, they may cause threat to life. Figure 1c shows pulling apart of gas pipelines and electrical control panels, which can cause both direct and indirect losses. Nowadays, with increasing sophistications in buildings, seismic performance of non-structural element is becoming more important. In many earthquakes, economic losses due to damages in non-structural elements have been quite substantial. Now let's discuss how do we protect non-structural elements. Non-structural elements can demonstrate either acceleration sensitive or displacement sensitive behavior during earthquakes. Let's discuss them one by one. Acceleration sensitive non-structural elements may topple or slide if not anchored adequately to structural elements. For example, this diesel generator unit on a floor, artifacts in museums. So what do we do? We secure non-structural elements with structural elements through anchors, which should be designed to resist the induced forces corresponding to accelerations developed in non-structural elements. Next is displacement sensitive non-structural elements, which can bend, compress, or stress by large amounts during earthquake shaking. For example, glass facades, water and gas pipes, electrical lines. Also, these non-structural elements are significantly affected by flexibility of structural elements and their deformation. The connection of these non-structural elements with the structural elements should be designed to accommodate relative displacements generated between support points on structural elements with adequate slack. The third category could be non-structural elements which are both displacement and acceleration sensitive, such as false ceilings suspended from floors above. These ceilings may not only pull out vertically from slab, but also swing laterally and knock on the wall. These kind of non-structural elements have to be designed for both forces and relative displacements. The strategies adopted for design of non-structural elements in a building and their connections with the structural elements are now being explained to you through this figures. Figure 2 shows non-engineered strategy. Generic non-structural elements such as glass bottles or shelves, crockery cannot be individually secured, but can be protected with simple strategies such as hold back strings or front panel plate as shown in this figure. Now let's see this figure 3, which shows prescriptive strategies. Factory made reasonably large non-structural elements such as cupboards, refrigerators, laboratory equipments, large panel glass windows. They often have manufacturer prescribed protection or encourage details provided at the time of purchase, such as tying or bolting, as you can see in this figure 3. There are engineering strategies as well, which are shown in this figure 4. Large, specialized, massive non-structural elements such as cooling plants or air conditioning systems, billboards, and those whose failure can be critical as fire hydrant pipes running along building height require formal design calculations for protecting them. Figure 5 explains non-structural elements in upper level of buildings. These non-structural elements and their connections to structural elements must be designed for shaking expected at those floor levels, as this floor shaking can be different and even higher than the shaking at the ground level. Therefore, always remember non-structural elements that project vertically or horizontally from buildings at upper elevations need special attentions. Countries like USA have made special provisions for engineering design of non-structural elements and their connections with structural elements. This is all about earthquake tip number 27. You can download this tip from www.bmtpc.org. The next earthquake tip, that is tip number 28, will be on what is confined masonry construction. Thank you.